Yeah, g'day, Mark here, and welcome back to my channel. Now, I'm just in the process of installing a direct readout on my surface grinder, and last week I was making up all the bracketry to mount the linear encoder on the cross slide, and this week I need to do the same for this vertical head unit. The difference here being that this needs to go inside the machine, which is going to be a bit of a nightmare. Now last week I also showed the fabrication of this gutter system to help return the coolant from this bottom corner of the table down into the coolant tank. And there were quite a few questions as to why I didn't just run a hose directly from the table back down to the coolant tank. Now on the one hand, this is a lathe coolant tank, and for grinding I'm going to need to add an additional module above it which has settling tanks to help filter out the grinding grit that gets produced. The drop in coolant from the table down to here is not going to be a yard like it is now. It's probably only going to be a reasonably short distance. So a tube flexible enough to take coolant from there back over to here is probably going to get flogged to death in no time as the table reciprocates backwards and forwards. And the second issue, you don't want any drag on the table of a surface grinder, because any drag there is going to show up directly in the surface finish of ground parts. Now to mount this linear encoder to measure the height of the grinding spindle, the best way to get it away from all of the grit and grime will be put it inside the machine. And the challenge for doing that has got to be access, because I'm going to have to do all of the installation through this panel. At least reaching in and installing it through this panel is how my mate Luke did it on his Jones and Shipman 540. Now unfortunately, I don't think there's any form of quick disconnects on any of these electrics, so I'm going to have to probably work around them as well. So you can see there's a movable casting here, which the motor attaches to, and then I've got the stationary castings on the side. So it's just a simple matter of bridging from like here to here with the linear encoder. So Luke sent me this one photo showing the slide mounted before he attached the head reading unit to the motor, and that's what I've got to go off. So this is going to be one of those cool jobs, kind of like working on old British aircraft, where you have a choice between seeing what you want to do, touching what you want to do, or getting tools where you need them, but not all three at the same time, and maybe not even two of them. And it's all covered with black grease in there, of course. So I just had a bit of a chat with Luke, and compared to his setup, he's got a cast rib that comes right across this section right here. And because I don't have that, it's going to be a little bit easier to mount these scales. I've just realized I was planning to mount the reed head off those screws there, but that's already rubber mounted, so that's no good. The mount bracket to the reed head's going to have to come off somewhere that's not rubber mounted, somewhere further back. Since I don't have to worry about a rib there, what I'm going to look at is how vertical is this raw casting face. Because if this is close to vertical, then I could probably just mount the scale directly to it and shim the scale to be vertical. To adjust in this direction, I've got the slotted holes, and to adjust forward to back in this axis, maybe I can just do it with shimming. So what I need to do here is clamp this scale into position and then get a clock onto it and just measure how much variation I've got forward to back against vertical. Like that. So all I did here was just using wedges, adjust it forward to back until it was sitting vertically, just to make sure that I could do it with a reasonable sort of shim pack. And then I also put the clock on the side and nudged it till it was vertical in the other direction as well. So that looks like a good location. Now I just need to punch the top hole location, drill it, tap it, mount the screw at the top, reset it vertical, and then transfer punch the bottom. Now if you want a good drill in a tight location, nothing beats a windy. So this is my lovely Sue. I bought this in the States some years ago from probably Aircraft Tool Supplies, I'm guessing. But it should be perfect for this job. Going to be drilling 5mm and then tapping M6. At the location of the bottom mount hole, the casting curves away, so I'm going to want some sort of a guide bushing to make sure that the hole goes through square and in the right location. So for that I'm going to use a bit of square bar. I'll just chop it off and put the holes in with the drill press to make sure they're nice and square. Right, that's my drilling jig finished. Right, now I can install my drill guide. First I'll install that top screw and then I'll put a clock on it and get it vertical-ish. Then drill the hole. Wait a minute. That's not going to work because that hole is behind the hydraulic motor and the hydraulic motor is too close to it. So therefore, that drill's too long. But that whole hydraulic unit, hopefully I don't need to remove it completely. I just need to move it. Okay. Okay, so here we can see that that was a crappy idea. The wall thickness is too thin and therefore the drill just milled out the slot. Luckily I did that before it started drilling into the cast iron, so I haven't done any damage yet. But what I'll do, I found just a nice long bushing and I'll just I decided to use a stud in this lower location because then I can put a nut on it and use that for the adjustment, leaving the top fixed kind of permanently. So I use my clock again to get it nice and straight, but I'm not going to show that again. In the meantime, let's assemble and test the actual display unit. At the moment I was set up for a TPU using an external filament heater. Right, just let me unload that. Wait a few seconds for it to warm up. So far I've only used TPU for things like seals, so I've probably got a lifetime supply of it at that rate. Now to print this housing, I'm kind of tossing up between carbon reinforced ASA because it's strong, or this ABS, which in the colour olive seems to be a near perfect colour match to RAL 6011, which is my favourite for painting machine parts. So I think I'll try that. How does it refill? Right, so this is now the back plate of the monitor mount. Not a bad mix of green, it's maybe slightly brighter, but kind of close enough. For the VESA mount, I need to melt in 4 M4 captive nuts. Mail time. Wow, that's some weird packaging. Very weird. Oh. Cool, so this is the mechanical lockout that prevents both of these contactors being activated at the same time. So I guess this goes in like that. All right, once those are together, you use this bit up the bottom to lock them. Right, that's now one locked out unit. Okay, so these are the M12 4-pin connectors I'm going to use to connect my DRO up to its head unit. Right, I've now printed up the rest of this unit. So it gets this body. Unfortunately, this part did have a bit of shrinkage. It was printed this way. And despite giving it 5mm of brim, I still had a bit of lifting on this corner and this corner. Now, I did try reprinting it, but that was a much worse failure. At this stage, I'm a bit undecided whether to just bolt it back onto it and accept that it's a little bit warped, or whether I should reprint this part in ASA carbon fiber, because my understanding is that the carbon fiber in it helps to restrict the amount of shrinkage it has. For now, I'll just go ahead and assemble it. Stefano designed this just to go together with wood screws, so I'll just use those. I probably should have looked up what the correct support material is for ABS, because I just used the ABS itself and it looks terrible. But luckily these bits are not visible from outside. Right, and since my mate Luke's come back from Chicago, he's brought with him either a repaired or replaced pie.
Replaced, I think.
Okay. So how many of these DrDros do you now have installed?
I only have 4 at the moment.
And that would be on lathe?
Yeah, milling machine, surface grinder and the cylindrical grinder as well.
So for the lathe, have you already got the electronic lead screw up and running?
No, I have not got that up yet.
But you've got all of the parts?
Yeah, I haven't mounted any motor yet. Got the encoder on and linear scales, but no motor.
Will you be installing a DrDro on your Clarkson?
Maybe. It's the arrow's probably bigger than the machine, but
All right, the little baby wrenches or spanners. Nope, must be a 5. Right, here goes the hat. So with that in, let's plug it in and see how it works. I haven't taken the plastic cover off yet. I'll do that once I'm finished making up the housing. Alright, here we have it. So at this stage I've only got one slide installed and it's super sensitive. So how do I set the slide scale?
so you'd have to go in the settings page.
Yeah.
Would be
X.
scale 0.
Scale 0. We'll call this one, it's going to be the Z axis.
Yeah, so you can just...
Okay. So ratio is...
So this is a 0.1 micron scale, so it should be
10,000.
10,000 to 1.
Yep.
You just put...
And again.
Yeah, 10,000.
Sync ratio, don't need any of that,
Yeah,
do we? It's
that's-
not a spindle.
So let's go back.
Well, that was easy. 157 through to minus something or other. So now we can put it, how do you zero it? Just there,
Yep.
zero it there, and now... Okay, so, oh, and of course I'm limiting my travel because I still got the plastic guide biddies on there. That's why I can't get the full travel out of it at this stage, but that doesn't matter. Cool. All right. And it's got a whole bunch of other functions that I'm not going to use at this stage, but...
Yeah, probably, but you can add probably
So at the moment...
an extra digit here.
Oh, yeah, to give us microns.
We probably have to refresh the page. Yep.
Okay, yep. So now we've got indication in microns. Cool.
But technically, I think it needs an extra digit for 0.1 of a micron.
Mm.
I'll change that to 4.
And just
it's the easiest. Just change
inch. Okay, now we've got our. Now we're reading out in ridiculously small units. That once it's installed, I'll probably reset that back to 3 digits because there's no valuable data in the fourth digit, is there? Very nice.
It depends on the accuracy of the scales as well.
Mm.
Not sure how
So
accurate they are to.
And I can also change the format of color, right?
Yep.
Okay.
Home digits. So you could change these to
RAL 6011. Must be somewhere up in here, huh? But there we go. Green on green.
Close, I think.
Yeah, it looks reasonably close. Very cool. Okay, so now I've got that slide nicely adjusted both this direction and this direction. So now I'm going to need to make a bracket to hold the reading head, and for this I'm back to some cardboard again. Lucky I've had a number of purchases lately, so I've got plenty of cardboard. Right, so my gusseted bracket is going to mount down here below the motor. I'll have to drill 2 holes in this cast iron here. I'll just put a wee bit of radius on the corner so that I don't touch this guide wheel which guides the whole vertical slide. And then over here it picks up the reed head. Okay, this is what the result of my fantastically accurate origami. So let's just flatten that out and see where we can cut this from. Obviously didn't glue this very straight, but they can just continue straight along. So I said this needs to be about 1 inch and 5 millimeters. So I want a nice wide curve through here. Angle grinder, save material. Right, with the basic plate set out now, do I drill this first while it's flat? Probably shouldn't I? But it would be easier. So I'm mounting off those 2 holes. So if I zero that, the pitch between the 2 of them is going to be 2.82 inches. That looks roughly horizontal, doesn't it? Okay, I did overbend it. Nice. So it turned out that putting the slotted holes in this side to pick up the reading head before doing the bend was a big mistake because the bracket ended up too long and the slots were off the edge of the head. So I had to cut it down and put some more slots in. Right, for the gusset plate, I've already given it a bit of file up to try and make it square. To strengthen it, needs to fit down in that radius. So it looks like probably 0.295 of an inch is about the right radius. Right, well, after a quick clean up with the sandblaster, it's about ready for welding, but I think I'll just offer this up first without the bracket on it. Just do a final check to make sure everything aligns before I start welding. Okay, so moving down, I've still got probably another inch of travel before I hit the bottom of the casting, and I also got about an inch of travel before I touch the surface of the table, so I think I will put a relief in it. Yeah. It's certainly safer. But I can now drill the motor casting to carry the bracket and then weld the gusset onto it. Okay, that didn't work because by having the bracket straight out at that angle, I'm now hitting on the motor mount, and therefore the bracket doesn't mount properly. So I need to cut those tacks and move the bracket down a bit. Right, for my next shot at this bracket, I've just put a nice bend in it here, so it can sit roughly like that and should now have some clearance. So with that bracket now welded up, it's time to install it, see how it works. Whoops, I dropped a screw and had to go all in to try and find it. Overall, the access really isn't too bad. I mean, it's a bit of a contortionist exercise, but you can get the job done. Oh wow, what do we have here? Far out.
It's a yellow submarine birthday cake.
For me?
You wish.
Well, this looks like it'd be perfect for like an 8-year-old.
It is for an 8-year-old. And she's a big Beatles fan.
You made a fantastic job of this.
Thank you.
Right, well, I've just bodged this up now. Let's see if it's all going to work nicely. Cross slide. This is the Z axis on a surface grinder because it's in line with the spindle. I need to change the scale. So we're going to have scale of axis 2. The denominator needs to be 10,000. Back. Cool. And now the vertical, I'm calling this the y-axis. And then we can slowly wind up the head, or we can dial in microns. Very cool. Now obviously this DRO's got a bunch of other functions because it's capable of being an electronic lead screw or indexing on the surface grinder. I'm probably only going to use it as a basic system. So I think I'll talk to Stefano about deleting all of the indexing and the 2 extra axes and making everything just bigger and easily readable. Although it's very readable as is. Fantastic unit, Stefano. Thank you very much for donating it to the cause here. I'm now out of time for this week, but I'm really glad I got those brackets completed and the vertical scale installed. It's going to be a real game changer for this machine to have digital readouts, so I'm super happy about that. Now I do still have a fair bit of work to do making up the final housing for it, making up and fabricating some sort of a swing arm for that to mount to, making up the final cables and just dressing the whole cable runs. Thanks a lot for watching. I suggest you wait a sec for this video that's going to come up here because that's going to be the one the algorithm thinks it's just right for you. Thanks a lot.